Kia ora, here's the differential equations question from the November 2014 paper. This is paper 31 again. So the integration in this question is probably easier than usual. The interesting part comes in part 2 of the question, and I am going to do both parts in the one video because they're pretty closely linked. So this is very topical. It's all about the tax charged on each litre of petrol. And we've got revenue per year is $1 million, and the tax rate is X dollars per litre. And we're given this differential equation. So that's the end of caring about the tax on petrol. The rest is just solving a DE. And we're told that when the tax rate is 50%, no, not 50%, 50 cents per litre, sorry, then the revenue earned by the government is a very low $16.8 million. So obviously a very, very, very small country. What we have to do now is the usual. We solve the DE and we get an expression for R in terms of X. So that's telling me don't leave it as the log of R. Go right through to the end. So let's do the usual thing, separate the variables and go from there. I'm going to pause this and do some of the easy stuff first. Okay, so I've separated the variables and we're ready to integrate, and we get the natural log of R is equal to the natural log of X minus 0.57X plus C. Now we were given one condition, which was when X was 0.5, R was equal to 16.8. So there's nothing nice about the numbers in this problem, unfortunately. So if we substitute that in, we can work out our constant. So just doing that carefully, 0.5, not 5, gives me C is equal to, now I'm going to just leave that line for you to work out, but we get C works out to be 3.799526, and I'm going to round that to 3 significant figures now, okay, because I'm about to chuck that into my DE. You can keep it unrounded if you want to. That gives me the natural log of R is equal to this. Now we want to get an expression for R, so we're going to do e to the power of both sides. We'll do this nice and slowly, so e to the power of all this. And now, of course, I'm going to break those up into separate bits. So we get R is equal to X times e to the negative 0.57X. And I'm going to split this one as well, although you could just leave all of this up as a power. That would be okay. But working that through, this constant works out to be about 44.7. So we get an expression for R of 44.7x e to the negative 0.57x. Okay, so that's rounded to 3 significant figures in there. Now, the next thing that we're asked to do, so that's the first part of the question, which I think was 6 marks. The next thing we're asked to do is to look at the limiting value of that. So I'm going to go back to the question now. Okay, so this model predicts that R can't exceed a certain amount. Find the maximum value of R. So just taking it slowly, we know that for a maximum, the derivative must equal 0. So what I'm going to do is to solve this equation for when it's equal to 0. Whoops, wrong pen. So for a maximum, so the maximum is also my limit here, we have dy by dx, dr by dx equal to 0. In other words, there's no more growth in revenue from changing the tax rate. Okay, so what was dr by dx? Well, we go all the way back to the start, and we had that dE. So we want to set that equal to 0, and we know that R is not equal to 0. So 1 over x minus 0.57 is equal to 0. 1 over x is equal to 0.57. X works out to be 1 over that, which is 1.75 4386. So I'm not rounding there. I know I'm being slightly inconsistent, but never mind. Okay, so that's my tax rate of that is going to cause me to get as much revenue as I can. What I have to do now is to find the limiting value of revenue. So I want to take that X and now substitute it into my expression for R. So R was equal to 44.7 X e to the negative 0.57x. So I take this and I substitute it in. And once I've chucked that into my calculator, I'll write it out here. We end up with 28.8, and I think that was millions of dollars. But I'll have to go back and check. Okay, so a really nice, slightly different differential equations question. And we've seen a little bit where the question does ask me to find a limiting value. Okay, so make sure that you're comfortable with what we did here. We found a maximum value by thinking about when there was no more growth in revenue. So we just solved for the derivative being equal to 0. Thanks for watching. That's all for tonight.